So now we are all set to go for the layout. So to create the layout, go to the inverter cell, right click on it, create new cell, right here INV, and select layout over here, inverter, and Mos over here, then OK. You see the icon has changed here, and this is your schematic that we had designed in the last tutorial, and this is your layout. Okay, just double click on it and go to components. You'll see all the component lists here is changed now. So you have Pmos and Nmos over here. Let's start with our design. We'll take Pmos, and we have to rotate it actually. You can use Ctrl+J as a shortcut key. So this selected box with the white color boundary is actually your poly, and as we know, we have to double the size. So just press Ctrl+I and we'll just double the size, that is 20, right? And Nmos, will place Nmos over here, Ctrl+J to rotate it, and Ctrl+I to open the properties. Width is 10. Okay, now we need to attach an active region to this, that is our source and drain region. Okay, so this is our Pmos, so Pmos will have P active region, P active. Ctrl+I will increase the size of this also, so that it would be of same size. Okay, so more the active region, it's better. We can copy this and put it over here. Then we have inactive for our Nmos. Ctrl+I, this is of size 10. Okay, we are making the connection as we had done in the schematic. It's the same way, left click and then right click, Ctrl+I, 10. Okay, so could you see this line coming up, and active spacing is 3.5. I'm keeping the space between this poly and active as 3.5. What will happen if I stretch this inside? Error. It's showing an error. It's saying n active spacing is 2.5, minimum is 3. So we are keeping it 3.5. These are some fundamentals from the Foundry. Okay, now I just want you all guys to revisit the schematic design just to see the connection. Okay, we see that our input of Pmos and Nmos is shorted. Similarly, we'll short our inputs over here. Select this and right click on this. Thin pink color line should appear over here. That is actually a poly, that's color of poly. Then we give a contact over here. I selected this contact because it's metal and poly contact. You can see the name over here, so just keep a watch over here. It will show, see, metal 1, polysilicon 1 contact. So I selected that and connection. Okay, we are done. Then again go to schematic. Our output is actually connected to the active region of Pmos and Nmos, that is this part. So this is shorted. Okay, we'll short this. So now here you got a metal line. So this is blue line is actually a metal 1 line. So now we have metal 1, so we have to go to the upper layer, that is metal 2. Here it was poly, above poly we have metal 1, above that we have metal 2 layer, then metal 3 layer, like that. So we go up and up. Okay, so this is metal 1 to metal 2 contact. We'll place it over here, we'll connect it. That's great. Now this is my PMOS, right? So PMOS is fabricated in N well, so we need to have a N well over here. So this is N well, and connecting it over here. I'll increase the size of this to be 20. Keep it more, otherwise it will give you an error. So keep the size more. Okay, so I'll connect it over here. Okay, this is because my other end of the active region was connected to VDD, and the other active region of Nmos is connected to the ground. We'll do so. For Nmos, I'll take a P-well. So I'll connect it over here. Okay, fine. So now our inverter circuit is actually ready. But before we start simulating it, we need to give the names and export the pins. So similarly, in the similar way we had done in the schematic, we'll name the PMOS over here. So the name is not visible over here, so press Ctrl and click on it, it will get selected. Okay, so we give Pmos. Remember, always capital. Okay, control selected. Great. Nmos. Now we'll name this as input. We have to export it. Create export in. Okay, now this is the thing. The pin export name should exactly match the pin export name that you have given in the schematic, otherwise it will give you an error in the later stage. So make sure you are doing it properly. Output, because the output node in the schematic was named output, and make sure you choose the proper export characteristics over here, and it should be same as that of schematic. I'm saying this again and again because later on it will give you an error, and it's really very difficult in the layout to find an error and then rectify it. So better to not give any chance to create an error. So we'll export this VDD, and we are gonna select power over here, and we'll say ground for our Nmos PUL. So now we are fully ready, but we need to write a spice code the same way we had written it in the schematic. So I'll just copy paste it, Ctrl+C and Ctrl+V. That's it. And okay, before simulating it over here, in a layout, always do two things. First is DRC. DRC stands for design rule check. It checks whether your design follows the rule. So every foundry, you remember we had seen the C5 model. That C5 model actually comes from the foundry. So Foundry gives you a set of rules as well. So DRC will check your design for all those rules, and if it is not following the rule, it will give you an error. So let's check for it. So we'll check hierarchically, and in the electric message you'll see no errors, no warnings. If there are any errors, you will see the errors over here. Okay, right now there are no errors. Then you do NCC, that is schematic and layout matching. So yes, this is the reason that I was telling you to give the same name, same connection as that of schematic, because we always do schematic and layout matching. It's also called as LVS, that is layout versus schematic. uh, so it says export match. So our design is gonna function properly. So the reason why we do this LVS is we just want to make sure that the circuit which we have created in layout will function the similar way it functions in the schematic. Okay, so now we are done with DRC and NCC. Now we'll go for simulation result. Okay, put output, that's great. We got the expected characteristics, output falling down, input rising up. Okay, just for the excitement, let's check the spice error uh, error log. So the values have changed little bit. Now why so? Why our values got changed? I want you all guys to just think about this. In the next tutorial maybe we'll discuss about this. So till then, bye bye.